Hello, welcome to the day 17th of Advent of Cyber. Let's see what's happening in the city of Wereville today and where can we help the elves get back to their sock mass preparation and for the big event that is coming up, the sock mass. So let's dive into the storyline and see what we have for today. And with the story here, it goes Mix Kitty is imprisoned in King Malhare's quantum warren. Sir Breach Blocker 3 was put in charge of securing the fortress and implemented several access control to prevent any escape. His defense are worthy of his name. However, Mixkitty managed to send virtual clues to his team using harmless bunny pictures. One message revealed that 5 locks needed to be disabled to secure an escape route. The locks can be broken by examining their logic and leveraging the system's built in chat for the guards. They can be eluded in revealing vital details or even passwords. However, you will need to speak their language. That sounds interesting. So, today's learning objectives are to introduction to encoding or decoding, learn how to use CyberChef, identify useful information in web application through HTTP headers. That sounds way interesting than what I had thought. So, do I need to start an attack box today and do I need a VM to start today? Yes. So, let's click on both of them. And while that's turning on, we can continue reading through today's task that is there. So, going to the task number 2, encoding and decoding. Encoding is a method to transform data to ensure compatibility between different systems. It differs from encryption in process and purpose and process. So encoding and encryption, though they're giving a description of what is encoding and what is encryption and the differences between encoding and encryption. Now, generally when speaking, we consider both the terms encoding and encryption to be a single term itself. But in practice and even reality, the term encoding and encryption both differ a lot. Encoding is something that we can actually get back the encoded text. It is something where we are just converting them for the purpose of making them look a little bit of secured. But where in terms of encryption, it's completely like literally encoding it in a form where we cannot retrieve it back. They're also obfuscated and encrypted, but we can't get back those terms which are originally encrypted. But whereas in encoding, you can decode those codes back with appropriate keys and appropriate salts which was added to it. We can get back the original text of it. So let's look at the comparison that they've given us here. It talks about purpose, process, security, speed, and examples of it. So, talking about encoding, the purpose of encoding is for compatibility and uh, usability. Sorry, it's for compatibility and usability. When it comes to encryption, it's about security and confidentiality. Coming to the process, encoding is standardized, where we have a single standard framework of how a image or how the key that you're passing in is going to be processed by using some methods and systems which are meant for encoding them. Coming to security, they provide no securities because you can get back the original text if you have the right keys and right salts which was added to that encoded text. Coming to speed, it's really fast. That's cool. And examples are base 64. Base 64 are generally seen in all kinds of applications where you just want to obfuscate some text into something which is non-readable. Coming to encryption, the purpose of encryption is for security and confidentiality. It's like, let's say I have a bank account and I don't want my name, my email IDs, or IDs of my bank accounts to be displayed to anyone. So I want it to be more secure and confidential itself. I don't want anyone to be able to use any mechanism to get back what I had originally entered into that parameter there. So that's where I want security and confidentiality, and encryption comes into that place. Coming to the process, it uses an algorithm and a key. Here too, even in encoding, there is a standard of algorithm that we use for encoding. But even for encryption, they use a certain algorithm and a key. But those algorithms are not reversible. Then coming to encryption, the security, yes, they are highly secured. That's why we use it in a security environment. Coming to the speed, it's slow because it needs to use a higher bit values of encryption standards and algorithms. So they take a lot of time to just encrypt one single text. But modern computers are really fast for doing them. Examples are TLS, these are certificates for web application certificates. Okay, now moving ahead. Decoding is the process of converting encoded data back to its original readable and usable form. Cyberchef. Cyberchef is also known as Cyber Swiss Army Knife. Ready to cook some recipes? Okay, I know that reference where it is coming from. So, Cyberchef is a tool which we use for encoding, decoding, or even sometimes encrypting something that we want to do. So, it's a popular tool and highly used by all professionals in the field of penetration testing or web application testings everywhere. It's basically a go to tool. That's why it comes under the Cyber Swiss Army knife. Now, areas that it looks into are operations, recipes, input and output, and the descriptions associated to them. So, operations are nothing but the repositories of what kind of operation do we want to perform into the input field that we pass in. Then, recipe is a fine tune and chain that operation area. It's nothing but if I want to do some changes. You know what? Let's open CyberChef and compare them side by side about what they are actually talking about here. So we have multiple tabs here. This is the operations tab. It's wherein we can see multiple type of algorithms or operations that we can perform. Something like it is going to convert to base 64, or we want to convert it to hexadecimal, or we want to do some URL encoding, decoding. So all those operations are here. Those are the set of algorithms that we can use for performing any of the specified tasks that we want to do. So you can list here and you can even search for them. So from or to base 64. So you can use these parameters for searching. Now the recipe is the place where we can do some changes. For example, I want the base 64 to be using some other set of standards of base 64 encoding algorithms. So I can say I can use XML, or I can say I want to use the ROT algorithm, or I can say many things which is present here. So it's basically like a recipe tab. What exactly do I want? I can get them all here and then modify, or I can set some operations other than what exactly is there. So I can say I want the delimiter to be set to colon. So I can specify all those parameters there. So these are the recipe tabs. What I will do is I will take one recipe which is base 64 and keep it to the default. Now in the input tab, if I type my name, so let's say please sub to my channel. So this content, which is the input that I have passed into the input parameter, is going to be using the algorithm of base 64 with the characters that we have given there into a output. Now this is a base 64 encoded character. It's not encrypted, it's encoded characters. So if I take this in and let's say I'll open up another CyberChef window here in the side by side. Here, if I pass in the same input, why am I getting so many ads here? What is the difference? Oh, this is IO and this is org. Let me change the URL here, .io itself, because I don't want all those ads to come in. Okay, here, if I input the encoded character that I have taken from here and see the operation, I want this character that is being passed in the input field to be decoded. So I can say from base 64, drag it and drop it here. I can see the text back again. So again, this is encoding because I can get back the original text when I pass in the right algorithm to it. Here I've set alphabets to be the contents here, the one same thing that I've originally passed in. If I do XML, there are no changes right now because there is no delimiters and parameters which is set to the same thing there. So we can go with the standard itself. So that's the input, output, and recipe tab there. Now, coming back here, they give us a simple example. Try your first recipe, open either the online CyberChef version on your regular browser or use the offline CyberChef version available in the bookmark section of the attack box. Drag and drop the two base 64 operation from the operations area on the left side to the recipe area in the center and add I am root in the input area. So I guess we have done the same contents here. We can skip this part and get into the inspecting web pages section. Besides the rendered content of the web page, your browser usually receives and can show additional informations. For this challenge, you will get the chance to have a deeper look at the information and put it to good use. To do this, depending on your browser, you can access the functionality as shown below. So they have opening the developer tools. So they are giving an example of how do we open the developer tools in different browsers. For example, Chrome, Firefox, Edge, Opera, and Safari. So in our case, we have most probably Firefox itself. So it's pretty much simple and easier in Firefox. Let's close that and let's open the Firefox browser there. Let's just follow these sections in random pages so that we can see the exact steps for doing it. Opening up the browser here, let's click on this hamburger icon. That's what I call. So clicking on the hamburger icon to any page, let's select a page before that. Let's say google.com and search for, let's say, hi. Okay, it gave an error that we can't search like that. Okay, so let's say hi here. Then we get this page here. Now let's click on the hamburger icon, which is then the top, and then let's go to the developer section. So go to more tools here. Inside more tools, we get a lot of options. One is the web developer tools, remote debugging, browser console, and responsive design mode. All of these are there, but let's click on the web developer tools. It's the nice window that pops up right there. I'll open this in new tab so that we can look at it in a better view. Also reduce the screen size here. Uh, okay, that seems to be fine here. Now here we can view it in a clear manner. So what's happening? The VM seems to be stuck. Okay. Okay, this page is loading. Yes, it seems to be interacting now. Now, yeah, this is the entire page. We can see the console to be again here. We can even see the memory of it. We can look at the storage, accessibility, application. Inspector, it talks about how the web page is there. Now, the developers watching this channel, you can maybe understand this better because uh, if you are developing any web application and want to do some small modifications, see what are the changes that we can do. I at least personally, when I develop a web application, I edit from here itself and then go back to the source code and do those modifications. So this is the web page that holds the source code of the UI that you're seeing. And we can perform a lot of tasks here. We can even remove or edit any of the contents that we are seeing on the screen. It's going to be reflected only locally, but we see a lot of information here. We can even look at the CSS stylings that is present for the web applications page. All those informations are also seen here. More than that, if we look at multiple places, one is the network. We can look at other informations here, which is, let's say, what is this web page doing? We can see the network communication of our browser with its servers and what each of these pages are calling from the web page to the other servers there. So we see a lot of links to be seen there. So all of them are being requested and those accesses are being visible here. Now this is one of the images. Can we render them? Let's look at the images only here, and you can see slightly here the preview of that image is being shown. So we have a lot of options that we can do in this section. Now let's continue reading here. Let's not go too tangent out of this. Note, for better experience, you can reposition the console on the top right side of the browser. Look for the three dots on the right side of the console. So we have it here, and we can say we can dock it to the right. Yeah, so now we get a cleaner, better, and more view there. But I personally prefer it at the bottom. Again, it depends on your choice. Okay, now let's click on the check button. It says locked and loaded. Moving to the next section of the task. Key information. If not already, start the target machine, give it a few minutes to boot up, and then from the attack box, you can access the web page at this URL. Let's copy the URL here, copy it there, pass it through the clipboard, paste it in here, and then replace the URL right here. Press enter. It says Quantum Warren. King Malhare's fortress. Save Mixkitty from the grasp of King Malhare. Wow, this fortress looks really good. And also we can see that there are multiple levels. It says outer gate, outer wall, guard house, inner castle, prison tower. So I guess these are the layers that we need to break in to save Mixkitty from the horror of King Malhare's prison. Okay, let's get into the section where we can read. Mixkitty revealed some vital clues in his image. You will have to leverage any useful piece of information in order to break the locks. Below are key points to look out for. Chat in base 64 encoded. Try decoding this in CyberChef. This will be leveraged to extract useful information from the guards. Be aware that from the log 3 onwards, the guards will take longer time to respond. Okay, so let's come here and probably close that there. What do we have here with outer gate? Let's click on that. And we have the content here, base 64 there. So the username and password, it says bash main map. Let's copy the base 64 code here. Come back to CyberChef and call it as from base 64. So let's drag it and drop it here. It says all hail King Malhare. Okay, that's strange. I thought we'll get some content there. Okay, so saying hi, it just says you don't speak our language. Then that means let's do something else here. Let's change this from base 64 to 2 base 64. I'll close this tab there. Then drag it and drop it back here to base 64 again. And this time I will say hi here. I want to see what's exactly happening in that page. So coming here, I paste it here. Not that one. I copied this one. Let's come here, add it to the clipboard. And here, let's paste that here. Click on send. It gave us an input back. Let's take this. And you know what? Let's open a different tab itself. It's going to be way easier. So cyberchef.io, and then put this content here. And I will use this for just decoding it. So from base 64, drag it, drop it. It says, let's go. All hail King Malhare. What if I say, give me the password? Give me the credentials. I'll copy this and I will put this right here. Then add it here again. Click on send. Okay, we get a content back. Let's now take it, paste it here. Again, the same thing. Did we get the same output? Yes, we get the same output in spite of changing the output there. Fine. I'm not sure how do we go forward then. So guard name. This logic will persist throughout the levels. Make sure you note down the guard name for each level. Oh, okay. So let's try using default credentials then. Admin, and click on bash. Not enough. Do we get any output from that? No. Wait, I'm confused now. So that's the outer gate. It says access denied, but that page is not loading for me. Let's refresh this and click on admin and admin. Not enough. Click on bash, or what is it? Okay, this gives no response at all. Even if I press enter, it just gives nothing. So I guess everything is just stored here itself. Let's decode this. Let's decode it here. It says all hail King Malhare. But that is not of any useful here. Okay, is it somewhere that we need to see from the developers tab? Let's even see. Oh god, I just closed the entire tab itself. Uh Hopefully just continues from where I left. Yeah. Okay, that's good. So I will open up the more tools, then web developer tools. Reload. Do I get anything from here? I don't see anything useful. Is it there in the source code of this inspector? Okay, I don't see any comments either. Let's continue reading here. It says, username, this will decode to cottontail, and password, look at the level login logic and decode the guard reply. But I don't see anything that is useful there, nor did I get those responses. Okay, headers. Again, inspecting the page but switching to the network tab at this time. Make sure to refresh the page once after switching to the tab and select the first response. Okay, we were in the network tab here. We get the first response is going to be this. And we see the server information and other information there. What exactly are we supposed to see here? It says, it says cookie X level 1. Do I see that here? Or is it this? No, not these. Not these for sure. I see nothing there. Let's go back to the page once again from the beginning. Click on enter. Then go to easy level here. And in here, let's see for any of those information. On a network, I don't see those parameters of level 1 to be set there. It says vary cookie X level 1. Okay, I get an idea right now. What if I say the same thing to the guard? What would that do? It's just an idea which came to me right now. So let's try doing that here. Uh, does the window resize itself? Okay, what if I just say the same content to it? Pass in this and click on send. It gave me a bigger text here. So let's copy this text and put it here. It says, let's go, all hail King Malhare. Okay, but no other response than that. What else can we do? Nor do we get anything useful from here, nor I can enter any credentials and try to log in. I don't get anything out of the page. I'll just continue reading. Let's see what will happen later. Login logic. You will inspect the page and switch to the debugger tab. Match the lock with respect to the logic. You can also find helpful comment that explain what you need to cook in CyberChef. Okay, so we will find those information in debugger. Let's come here to static and okay, the size seems to be small. Let's open it in a bigger view. Put that out. And we have the logic here. So it's going to say the password logic. Okay, no. The user login logic is if the user clicks on OK, it should be the guard name. So username is going to be the guard name, which is Cottontail. So Cottontail is the username. Now coming to the password logic, if level is equal to 1, which is I guess is level equal to 1, CyberChef from base 64. Okay, pass okay is if it is equal to expected constant. If it is level 2, it's a different thing. Now, when it comes to expected constant, what do we see here? Can we see anything specific? These are for level 5. Maybe there is some constant already defined in this parameter. Okay, I don't find any constants to be defined such that we can directly enter those passwords. Okay, again, I'll just continue reading from here and see what can we do. First look, outer gate. Okay, it's time to see it's the fortress. Ready? First, identify the guard name and encode it to base 64. You will use this as the username input. Okay, it is Cottontail. So let's come here and replace it with Cottontail as the username. So this becomes our new username that we can pass in. That's good. Next, use the information from the page header, identify the magic question and encode it in base 64 as well. We see what is the password for this level, and we get that from L1 response from the tab here. Let's go to network. So let me refresh the page again. It seems to be not found. Let me pass in this itself here. Let's say this time it's going to be Cottontail. Let's copy that. Then coming to the clipboard, can I paste it from here? No. So let's come to the clipboard and paste that content there and pass that as the username. Click on bash, and now it says username. This will decode to Cottontail. Password, look at the level login logic and decode the guard reply. So, okay. So we again have to look at the logic there. That's great. But still, I am not able to find out why I am not getting the level 1 access there. Oh, okay, I get it. I get it. It's my fault. I did not see that it was set to images. I had set it when I was demonstrating something, and we see the level 1 to be here. Okay, I'm sorry. I get it now. So we see X level, which is 1, and it is going to ask the magic question here. It says, what is the password for this level? So that's going to be the magic question that is given to us. Yes, we are on the right track now. uh, I just went Hail Mary with that set of debugging thing. Okay, again, reading through this, it says use the encoded magic question in the chat. The guard will answer with the encoded level password. So we'll take this question that is present to us. Let's copy that, then paste it in here. And now I will copy this text, come here back to the cyber chef, paste this right there, then pasting it here, click on send. We get a different response this time. Let me copy this and paste it to cyber chef again, and it says here's the password and this is the code there. That's great. Let me just decode and see what is the password. It says, oh, this is again to base 64. Okay, let's put it here itself. It says I am so fluffy. That's the password. And let me pass it here. Oh yes, so we had to just give the raw password of it. So outer gate is open. Wow. So we broke the outer gate of the fortress there with base 64 decoding. Now that's fun. Now let's move back to the section here and continue reading. So we finished the section there. What is the password of the first lock? We can paste it there. And now let's go to the second outer lock. Second outer lock, outer wall. Excellent job breaking the first level. This level nudges the difficulty up a little bit. But don't worry, you will figure it out. Let's go. Again, identify the guard's name and save the encoded output for later. So we need to identify the guard's name and save the encoded output for later. Let's come here, click on the outer wall. This time it's Carrot Helm. So we will copy the guard's name, and let me also open up a text editor and paste the guard's name there. So we have saved the guard's name. Next, then extract the encoded magic question and retrieve the encoded password from the guard. Coming here, let's go to level 2 and we get, did you change the password? So that's the question, that's the magic question. So let's come here, add it here, copy the base 64 encoded text and paste it into the clipboard, pass it to the base 64 chat and send it there. We get a huge response. We'll copy the response and replace it into the input box and says, here is the password. Oh, I'm sorry. I'm pasting the same thing again. It's my fault. I'm sorry. I'm pasting the same content. Okay. It is my fault. I was pasting the same content. Okay, I get the password now. Okay, I get it. This is the username and the password there. Next, what else do we get? Looking again at the login logic, you can see the encoding is applied twice this time. This means you need to encode the decoded from base 64 twice. Do we see that in the debugger? Let's open this in a more free manner. Also increase the code more. Can we push this here to see the logic? Okay, here it says try and we have for level 2. So it's going to double from base 64 and it's going to be encoding it twice. We can see the functionality of the password being encoded twice to the expected constant. Well, that's great. So it means the password that we have here is what we have got. So let's take the username. This time it is carrot helm. Let's encode it once and try it with this. If that doesn't work, we can encode the username also twice. Let's paste that in there. And username is this. And the password is this one. So let's put the character there. Yes, so we broke the outer wall also. That's great. Now with that, what is the password for the second lock? We get it. Now let's go to the third lock here. So far, so good. As you saw in the previous level, the login logic begins to use chained operations. This will be trend for this and following levels. As always, collect all the needed information, encoded username, encoded password from the guard, and XOR key. So we have an XOR key for this challenge. So let's click on not enough and go to the guard house challenge there. Yeah, again, I guess it's the same thing. It says hail to King Malhare. For this time, it's the long years. That's the guard name. What is the logic for the third level? So CyberChef from base 64 and it's passing through XOR and key is the recipe key. Okay, what about the network? What does that say? We get the XOR recipe key to be CyberChef. So we get the key here and we get the question. There's no question. So we get the key there. And from the debugger, we know that the username is the username that is there. And maybe we need to be just passing in. What do we have for the password here? Okay, let's go with the username first. So let's do from base 64 and let's go back to the CyberChef XOR process. What is XOR? I guess is it told here? Some third time. Yes, I can see it here. But before that, it says from this lock onwards, there is no magic question. But sometimes you can ask the guard nicely to give you the password. It will be still needed to be decoded as per the logic, login logic. Be aware that the guard may sometimes fall asleep or take a long time to respond, 2 to 3 minutes. So keep waiting. The message short will help you get the answer. Even a simple password please will go a long way. Oh wow, we can be so kind to the guard then. Okay, if you look at the login logic, there's a slight twist. The password is first XORed with the key and then encoded to base 64. Theory time. XOR is a popular operation that, besides the input data, also uses a key. The process involves a bit twisted exclusive OR between the data and the key. They have given the logic gate representation of XOR and a truth table associated to it. You might ask, okay, but now how do I reverse this? Well, skipping the long math explanation, XOR has a magic property. When you XOR the result with the key again, the new result will be the initial data. Go ahead, try this in CyberChef. Put the two XOR operation one after the another, use the same key for both, and the output should be identical. Okay, that is getting into the hands on stuff, but I want to take a little bit of my own theory time out of this. So let's take a tangent here and get into Microsoft Whiteboard for the theory here. Now, XOR is pretty simple. So the logic of XOR is completely based upon the truth table that I'm going to be showing here. So let's type in XOR. Again, don't go with my handwriting. I'm writing on a tab and I rarely use the tab. So my handwriting is going to be pretty bad. But let's take this as an example. Let's consider some binary values. Let's say 1 0 1 1 0 1. Okay, so this is some basic binary data input which I've passed in. Now let's take a key in form of binary itself, and let's call this to be the raw data. So I will call it here as the raw, and I will take another key here, 0 0 1 1. That was pretty bad, 1, and let's take a 0 here, and I will consider this to be my keys here. Okay, so I have these two inputs with me right now. The logic of XOR is that whenever we get a uneven input, that is going to be considered as a 1 bit. And when we get an even input, we are going to be getting that response has to be 0. For example, if I get the input as 1 and other input as 0, the output of 1 and 0 is going to be considered as 1. In this case, when I get 0 and 0, which two are even inputs, in the sense it's 0 and 0, I'll get the output to be as a 0. When again, same case with 1, since it's 1 and 1, since both the gates inputs are equal, we get the output to be 0. Yeah, the tab is a little bit messy here. Again, we get the output as 0. In case of this, we get the input to be 0 and another input to be 1. So they are uneven. We get the response to be as 1. And in this case, again, it's uneven response as the input 1 and there is another input 0. It's going to become an output as 1. So this is going to be our final output of this. I'll call this as the output of the entire raw key and output. Now the logic of XOR is that if I have a secret that I want to hide and I use a specific key for XORing with this original message that I want to hide, I get the output here. So this seems to be quite secure, but the only problem is if I have the output with me and if I have the key with me, or let's say I have the output with me and I have the raw input that I gave it to it, I can find another parameter of it. So in XOR, if I have any one of the parameter with me and any two of the parameters with me, we can always find the third parameter which was used in the XOR operation. Let's take an example of it. So if I have the output with me already, let's say 1 0 0 1 1, and let's say I have the key with me which is 0 0 1 1 and a 0. In this case, let's put this here. This is the output and this is the key here. We can now retrieve back the raw input. Why? Because 1 0 is an odd even, or it's an odd combination. So we know the output of odd combination is always going to be 1. So we get back 1. In 0 0, it's an even combination. So we get back the output to be 0. Here it is 0 and 1. It's an odd combination. So we get back the response to be 1. In this case, 1 and 1, they are even combination. We get back 0. In this case, it's 1 and 0. It is an odd combination. So we get back 1 again. So here we can see that we have got the original text, which is 1010 as the output here, 10101. So that's a parameter. Now, let's say I have the output with me and I have the raw message with me. I can even get the key back. Let's take an example of that too. Let's take the raw message here at the top. It is 10101 and I take the output key which I have got from here. This is my output key. So I'll pass that itself as 1 0 0 1 1. And now XORing these two processes, which is 1 and 1, it's an even combination. We get 0 as the output. Again, 0 0 is an even combination, so we get 0 as another output. 1 0 is an odd combination, so we get 1 as an output. 0 1 is an odd combination, we get 1 as an output. 1 1 is an even combination, so we get 0 as the output. So we can see that we get 0 0 1 1, which is nothing but the same key that we passed in for XORing with the raw image. That's the concept that we're using here. Now, putting this concept into practical use, let's say in terms of the cyber chef, where we are using numbers and letters instead of a binary form, it becomes more complex to just show it on a whiteboard here. That's the reason we'll get back to the cyber chef itself, but using the tool to do the process of the same logic that I've explained here. Let's get back to our Kali Linux. So in our Kali Linux machine, let's continue reading through the process here. It says, you might ask, okay, how do I reverse this? Because we have got the question, XOR logic, and the username there. So how do I do it, right? Well, skipping long maths explanation, I'm sorry, which I did, XOR has a magic property. When you XOR the result with the key again, the new result will be the initial data. Go ahead, try this with CyberChef. Put the two XOR operations one after another. Use the same key for both, and the output should be identical. So they are passing in. I guess that's an example, or is it part of the challenge here? So we get the keys to be CyberChef here. And no, what all did we get here? Let me open the notes here. I get the password. Is it of this? No, it's not of this. So we get the long years to be the username. Let's put that here. This is the guard name. So I will name it as gname. And we get the recipe key. So we get the key here, which is nothing but cyber chef, right? Okay, and in the debugger we get the logic, which is that it is first XORed and then it is base 64 encoded. So that is the logic there. So what we have is nothing but the key and the username there. So let's pass in with the cyberchef, but let's take also this example there. So it says XORing twice with the key as my key and some input there saying XOR is fun. So let's take that example here. It's say, please sub to this channel, and let's take the recipe to be as XOR. Let's drag it and drop it here. And this time we'll pass the key to be as YouTube. So that's our key here. What do we get the output? The output is so gibberish, right? That's fine. If I put in another XOR and say YouTube as the key, I'll get back the content. So what's happening here is if I pause this or if I remove this entirely, this is some gibberish language. I can't understand exactly because it has a lot of space in between and other contents which it is not able to process it well. But with this, I am getting a content here, which is the output of my original text and the key. I'm getting an output here. In terms of the second XOR that we are passing in here, it's taking the output what is here and then again XORing with the same key which we have found and giving back the output of the original text here. So it's going to encode this with the XOR logic. Again, it's going to encode the same thing with the same key. So we get back the entire content to us in the same format. So we'll be using the same logic to be able to decode the contents there. But let's also read through the content here. It says, with the newly found knowledge, build the needed recipe to find the plain text password. So they're doing from base 64 and then XORing that logic with the keys and the contents that we get. So let's do the same thing. Let's put all of them back here. And into the input field, let's put in the guard's name, which is long years, putting it there. Then let's call for the base 64. So it says to base 64, we'll use the standard parameter itself. So this base 64 output is supposed to be XORed with the key called as cyber chef. We get this as the output. I hope this is considered. Looking at the image, I see that okay, we need to change it from hex to UTF-8, but still, it still looks quite messy, unlike the output that I originally got. Uh, it says from base 64. Did we get any base 60? Oh, we are looking at the password here. So, okay, let's ask for the password there. So, let's say instead of from, let's put it to password. Oh, sorry, to base 64. Let's drag it and drop it. Please password. Or what was the prompt which was earlier set to us? It is password please. Okay, let's copy the same thing. Password please. Let's copy this base 64 content and ask the guard to give us the password there. Paste that in there, pass the content there, click on send, and hopefully the guard is not sleeping. So till the guard comes alive, we know the username here. So we know the username. So let's generate that itself. Longius, pass it there. We'll copy the base 64 content from there. We just need to pass in the password, right? So let's put this content there and wait for the guard to reply us with the password. So let's take a small break. We get the response from the guard here. Let's copy the contents there, then see what exactly do we have. So pasting it there, I don't want it XOR right enough. I want it to say from base 64. Let's copy this and it says here is the password and a content is presented there. We can directly do it. So let's replace it here. It gives some random thing. What I will do is I will pass it through XOR now. So XOR, and we have the key which is cyber chef. I guess we don't need base 64 now. Do we need? Yes, we need. Cyber. Okay, is this going to be the password? I'm not sure. Most probably it is not, but it seems to look like that. So we can give it a try. If it works, it's going to work. But looking at the image, I can see it's IQ something. So, and it also looks like a character there itself. Oh yeah, it's from hex, right? So let's change to UTF-8. But still, no response from that. But if I close this, no. What is the original text? Let's copy this once again and pass this entire thing. Let me copy this, paste it in the input. So XOR, let me close this. Yes, so this is the original text. Let me replace that here. I get the response there. And it says, yes, Bugs Bunny. So that's the password that we have got for this. Okay. Pasting in the password, not that big. Let's go to the clipboard, replace it with the password. And pass in the password, click on bash. And yes, we cracked this vault also. That's good. That's fun. So now we are left with the medium one, which is the inner castle. That's good. Let's paste in the password that we found and go to the next task. The fourth lock, inner castle. We are almost there. In this level, Sir Beach Blocker 3 throws you at a curveball. Let's see how to tackle this. But first, go ahead and look at the logic, login logic before. We will not be needing the header information for this one. Okay, we are already in the login logic. And in the fourth level, it says hash lookup. So we need to look up at the hash that it is going to give, which means that it's not going to be base 64 or XOR here. It's going to be some random hash which we need to identify. That's interesting. So it says now after asking the guard for the password and looking for its reply, it seems to be a bit odd. Okay, let's ask the guard then. Let's ask the guard for the password. We have it here. Do we have it here? No, we don't have it here. So it says to base 64, right? So password, please. Password, please. Let's copy this and coming here. No, we need to also go to the castle here. Okay, now let's paste in the password please prompt, which is base 64 encoded. Click on send and we get the reply instant. Good that the guard was not sleeping. Now let's now let's decode this and put this away, XOR, and it says the password is, and it gives a very big text here. Again, it doesn't look like a base 64, and nevertheless we can try to do base 64. It says from base 64. It's some, again, random text there. It doesn't look like base 64. Usually base 64 is going to be ending with equal to sign, but this also doesn't match the base 64 format there. That's fine. Now, after asking for the guard for the password and looking at its reply, it seems a bit odd. At the same time, the login logic shows the use of MD5 hash. I did not notice that one. Yeah, it says here MD5 hash. The password is being encoded with MD5. So, okay, we have another theory time for it. MD5 or Message Digest Algorithm 5 is a cryptographic algorithm that produces a fixed sized hash value. While it is supposed to be a one-way function, meaning you cannot reverse it, pre-computed hashes can be leveraged to identify the input. Yeah, why was I even trying to this nothing but encodes the characters more. So there is no use in doing that. We need to be using some payloads or predefined like a dictionary or something like that, and then be passing in those for looking at what could be a possible password of it. While this is supposed to be a one-way function, meaning you cannot reverse it, the pre-computed hashes can be leveraged to identify the input. Putting the two together, the plain text password is password through MD5, and you have the hash. This looks like a job for crackstation. So let's open the crackstation.net there, and it says go ahead and open the site and paste the hash to retrieve the password. We can put that here, then say that I'm not a robot. Oh god, I have to solve captchas. Okay, let's click on motorcycles. These are all the motorcycles. Click on verify. Okay, good. And it's the first time that I actually get the hashes right. Okay, in the crack station, it has computed the hash to be as the password 0RD to be the result. In other cases, we might have to take a word list, let's say like a dictionary, which is like rocku.txt or something, and then pass it through that. It's going to compute for the MD5 hash, and then it's going to compare with the hash that we have there. So it's going to encode or encrypt the user list that we pass in to MD5, then it's going to check for it. We would use John the Ripper or something like that for doing it, but this is useful when we are doing a small word list comparisons. So I'll use this password here, and yeah, so we get the password of this challenge. What I can do is the guard's name is Lenny. I'm going to encode Lenny as the username there. Then coming here, I'm going to open the clipboard, pass in the clipboard's content to the username parameter there. And the password is here. Let's open clipboard once again. Paste in the password there. Click on bash. Yes, we broke that also. Yeah, I guess we are now becoming good at this. Let's paste that there and click on check. That's done. Now the fifth lock, the prison tower. Ready for the final hurdle? As the defense weakens, you can receive another hidden message from Mix Kitty. I can see you are ready to break the last lock. Be aware that Sir Breach Blocker 3 implemented different mechanism for the last lock, which changes occasionally. Make sure you match the correct approach when decoding the password. The sound tricky but not despair. You will find a way. Let's start extracting the information as before, noting down the encoded guard name. So coming here to the last prisoner tower, which is rated to be hard, and the prisoner name is Carl. So let's first thing is take the guard name. So I'll save the G name to be Carl. Okay, next what do we have? Let's go to the logic here and see what we have here. Uh, Here it says for the level 5, the constant is going to be the recipe is equal to the, okay, this is something, and let TP be equal to the password. So it is taking the recipe required to the recipe ID and R1. I guess this constant is somewhere defined, but I'm not interested in verifying where it is going to be. Anyway, we have the switch option here, which is going to say that, okay, this is initially verified to be set to be as R1. It depends on what are going to be our levels. It's going to be either R3, 4, 1, or all these. It's going to be from the range from R1 to R4. Depending on that case, it's, let's say if it is R1, it's going to choose this option here. If it is going to be R2, it's going to choose this option appropriately. So what is going to be the value of our recipe? It's going to choose that algorithm for it. If it is R1, we see it is going to be root 13, which is nothing but another algorithm. And then it's going to reverse that root 13 input, and it's going to do a base 64 encoding of it. Okay. If it is case 2, it's going to be the reverse of the password that we pass in. Then it's going to do string to hexa. Then it's going to base 64 encode it. Okay. If it is R3, it's going to take in the input here. Let's go here. It's going to take the input here. It's going to go with XOR. No, what is happening here? It's going to take the recipe key. It's going to take the key as a recipe key here. That means we can find in the console there. So it's going to XOR that, and that is being base 64, and this is being passed to the rot 13 algorithm. Okay, so this is quite tricky. I need to actually understand what the logic is. I understood the surface level of it though. If it is R4, which is the last case, it's going to take the input. It's going to use the rot 47 algorithm. It's going to do a base 64 encoding, and then implement rot 13 as another algorithm there. Okay, so we have multiple chances of getting any one of these algorithms there. What's the crisp here? What are we doing here? Let's go here. It says, additionally, note the recipe ID from the header and match the corresponding logic, login logic. Below is a quick cheat sheet for decoding each recipe. So what is our content for today? So looking at the network and level 5, it is R2. So which means that we need to be looking at the logic of this one, which is reverse from hexa. Then it's going to be base 64 encoding. Now this seems to be a pretty simple logic. So this is okay. So build the reverse recipe with cyberchef and extract the final password. Did I see a theory time? No. Okay, so that is it. So we are just supposed to be doing with that. Okay, anyway, that's fine. I thought of explaining the rot algorithm, but I'll take that to another day because I see my recording to also be taking a lot of time. So I'll take up the different encoding and encrypting algorithms some other day on some other video. So let's stick to the challenge here itself. So build a reverse recipe with the cyberchef and extract the final password. Finally, the last lock has been breached. You provided a safe path for Mixkitty to escape. Okay, so for that, before we get Mixkitty into escaping, we need to ask for the password. So, what was here earlier? So let's ask for password, please. This is a good thing that the guards are really kind to us, that they give us the password as we ask them. So let's paste in that, and the username is Carl here. So Carl is going to be the content which we need to encode. So let's put this away. Okay, let's put it here itself. So because we have two base60 for that, so we get the username parameter ready here. Let's paste in the username there at least. So we have the username there. For the password, we get the content. Let's take in from base64 itself. No, but we have a different algorithm here. We have got R2. So it says reverse. So whatever content is being given to us, that finally needs to be reversed. Before that, it needs to be gone through from hex and from base64. So let's search for from base64, and let's search for from hex. Okay, and we need to reverse the entire content that we get. So reverse, drag it and drop it. This seems to be weird. Okay, I had to go step by step. Okay, so we get this to be the base64 encoded character. Let's replace it here, and let's take the hex here. So we get the hexadecimal characters, and this is the encoded parameter. Let's paste that in there, and now we should get the output. But we did not get the output. That is strange. Delimiter is set to none. Okay, auto. What about reverse now? What is the parameter here? I have to see. So it says from base64 from hex reverse. Did I mess up the original payload then? So let's put that there. Let's put all of them away and start from the beginning. Say from base64, drag it, drop it. So it says here's the password, and I get the password there. So let's replace this there. So we get the hexadecimal character there. So now let's call for from hex, drag it, drop it. We get the content there. Now let's say reverse, drag it, drop it. Oh yeah, now we get it. So there was something wrong with that. So again, I can't read that. So what we'll do is nothing but come to the page here, paste in the password that we got, paste the password, click on bash, and yes, there we go. We get the final lock. So what is the password of the fifth lock? Click on check. That's done. Now it's time to copy the flag that we get. Let's copy the flag from here. Good. Let's paste in the flag and click on check. With that, we finished the task of this. Okay, so Mixed Kitty ran from the prison that he was present in. It says, as Mixed Kitty passed by the inner castle, she heard a thunderous voice. Why should the Christmas have all the fun? Mixed Kitty managed to get back to Wavell just in time as the best festive company was about to be hit by another disaster. Oh my god, there's another disaster coming at the best festival company. Okay, so if you found the decoding secret interesting, you can also check out the introduction to cryptography room, which dives into the world of cryptography. Let's click on check. And looking for the key to side quest 3, Hopper has left us the cyber chef link as lead. See if you can recover the key and access the corresponding challenge in our side quest hub. I'll be creating a separate series for the side quest hub, so let's skip that for now, and we can finish with the day 17 of Advent of Cyber. And yeah, that is it for this video. Meet you all on the day 18th of Advent of Cyber. Till then, stay happy, stay smiling. Thank you for watching. Meet you on the next video. Thank you for watching. Bye bye.